Just on time. Hello, everyone, and thank you for joining us for this month guest webinar series, starting soon by Gil Zilberfeld, or as you might know him, TestingGil, with his session about clean web testing. I'll introduce Gil in a few minutes. Some of you probably already know him, but before, I'd like to steal 2 minutes of your time and introduce PractiTest for those of you who are not familiar with who we are. I start with introducing myself. My name is Noah. I manage the marketing activities here at PractiTest. Thank you for joining us today, live or watching this recording. So a little bit about what we do. So PractiTest is a centralized testing hub. In an essence, we are an end-to-end enterprise-grade test management platform, which is powered QA intelligence and AI, connecting every aspect of testing from requirements to test execution and issues, integrating with some of the logos that you see here, but this is a sample and other tools as well. We understand that most companies that we work with work today with multiple testing tools as part of their stack. And in order to be a hub, you have to have everything centralized into one place in order for you to make data-driven decisions. We are a cloud SaaS solution. As such, we are maintaining the relevant certifications and compliance with standards such as SOC Type 2, ISO 27001, and GDPR, of course, hosted by AWS with data centers in the US and EU, not by our customers as sample here. And as I mentioned, we have end-to-end testing modules all the way from planning of visioning part with requirements and user stories, depending if you are working with the more traditional waterfall or the more prominent now agile tap, two core modules of test execution, test library in order to ensure and to encourage reusability, which is a challenge that we hear often, and test sets and runs to better organize the testing, issues to report them, and two different modules of reports and dashboards to visualize and communicate those findings and the outcomes which we test for. Okay, so that's a little bit about it. A snapshot of our customers. As you can see, we work cross verticals across the globe. I assume you know some of the names here. This is, again, a subsample of our customer base, just to give you some hunch of who we work with. We host live training and Q&A sessions. If you want to join, you're welcome to scan the QR code or visit our website, sign up for a free trial or for a demo session, or just come for those two events. If you like, we can also coordinate a dedicated session for you. And that's all about PractiTest. Thank you for joining us. And Gil, the floor is yours. Before I hand over to Gil, I'd like to say 2 words about Gil himself, in case you're not familiar with him, but you should. So Gil has been in software testing since childhood, which means something about 5 or 10 years. But I'm joking, with more than 25 years of developing commercial software. He has a very vast experience in software methodology and practices, all the way from unit testing to exploratory testing, design practices to clean code, API to web testing. He's done it all. Today he's going to talk about clean testing. But in general, Gil also speaks frequently in international conferences about testing, TDD, clean code, and agile practices. He blogs and posts videos on those topics on TestingGil.com. I assume Gil will also share this link, and his YouTube channel. And he's the author of Everyday Unit Testing. And last but not least, dedicated for our audience, on his spare time, he shoots zombies for fun. Anyone needs to have a unique hobby. We don't judge. Thank you for being with us, Gil. I'm handing over to you.
Thank you. Yeah, well, let's talk about zombies. No, let's not. Today we're going to talk about clean test. Specifically, we're going to talk about clean web tests. So I'm going to show you examples in Playwright, but what we're going to talk about today is things that are not language specific. I'm going to show things in TypeScript, but it could be like in Java or whatever you're writing. You're writing tests in Selenium. That's cool too. The principles that we're going to talk about are like sort of universal. Yeah, so let's leave this guy out and talk about me a bit, because you haven't heard too much about me until now. So I'm a I'm Gil. I'm a trainer and a consultant, and I work with developers and testers who want to make software better. That includes everything that Noah talked about and a bit more, and the zombie stuff. I'm also the author of 2 books. Yeah, no, you've heard about me enough for today. Let's talk about clean code and clean tests. So what are we talking about? We're talking about automated tests. We're not talking about manual stuff, obviously, because we can't code this yet. Somebody will code it for us very soon, like AI agents, but we're not going to talk about those today. Tests are code. Let's start with that. It doesn't go away. We can write tests in any code that we know. And a lot of the time, our tests are not really good. And there are reasons for that. Yes, they are working, but is that enough? And the answer is no, because writing tests is fun and they pass, but then we have to live with them. And the way we write tests, or we could write tests in different ways. One of them is like typing, like every other piece of code that we do. We can generate them. We can generate parts of them and fill in the rest. But they are different than regular code. And the reason they are different is that code, when I put in my developer hat on, I write some code. I know that at some point in the future, I'm going to go back into that and maintain it, and it's going to be painful. So in order to not to be that painful, I'm going to invest in it now and make it prettier, clearer, whatever. We talk about some ideas, some patterns that we're going to do. And if we apply these tests, we should have like the same idea about that. But we don't. And the 2 prevalent patterns are like, when we're done with the test, we forget about it. Like we move on to the next one. So the whole idea of refactoring is to have some code that works, and then you go back and you change it, and it still works. With tests, we don't have time because we never have enough time. We have finally completed an automated test. It works, excellent. We need to move on to the next one. So we don't go back to the first one. And there's a problem with that, because what do we do in order to get to the next one? Usually it's a sort of a mutation of the last one. So we take the ugly last one, we copy it, and we change it a bit. And like in a few minutes or hours, we have lots of ugly tests that we have to live with, but we don't go back and fix them. So our idea of how we write tests is different than how we write code. Therefore, our tests get, not sure if we'll say no respect, but less respect than actual code. So what is clean code? Clean code is something that if you look up on the interwebs, find many definitions of. I think the person who named clean code and took over the name is Uncle Bob, Robert C. Martin, but he didn't invent this. And many people said that clean code is hard to define, but some people gave some examples. So I will give you a couple of definitions. First one is from Grady Butch. Grady Butch was one of the people who sort of created the object orientation movement, part of Rational in the 90s. Cool guy. And he said that clean code is simple and direct. It should be written like prose. And think about the last code you saw, any code, not just that. And you think about, does it read like a book? And I bet it doesn't. And it's not you. It's us. It's also me. We need to invest in it in order to look for that. And we'll talk about why it looks like that, apart from the copy pasting that we already discussed. Another definition that I like is, or the description is by Michael Feathers. Michael Feathers wrote a book called Working Effectively with Lexicode. And I think like it's like if you would like to know about unit testing, this is like the Bible. And he said clean code always looks like it was written by someone who cares. The question is, cares about what? And any clean code that I write, basically, like I said, I'm investing now in order to have a better time in the future. And think about tests. Where do we go into there in the future? Some point in the future, an automated test fails. And usually it happens when while we're working on something probably more interesting. So we'd like to get back to that interesting thing as quickly as possible. But first we have to understand what the failure and find if it's a bug, or maybe it's not a bug, reproduce something, not reproduce, find out what's wrong, spend time on that tests, and then go back to the interesting stuff. So what is caring? Caring is about my future self or somebody else's time. Because like I said, in the future, I'd like to spend less time on maintenance and the painful stuff, rather on the new shiny stuff. So yeah. So having said that, you probably understand that you probably want to clean all the code, and that includes all the tests. So yeah, so we know we want to do this. We don't do this. So there's something called code smells. Code smells are patterns in the code that you look at the code and you say, something's not right here. And it's not like it doesn't do what it needs to do. It's not a bug. Code smells are like patterns that tells you, or anti-patterns that tell you that in terms of maintainability, this is going to cost us more in the future. So I have a couple of them here, and we'll talk about those today. It's not the only thing, but I want you to, when you go back to your work and look at the test that you have, pay a little attention to how these things manifest themselves in your tests, because we'll see how we can deal with those once we know they're there. The first one's duplication. Like I said, it's easy to duplicate code, like a couple of shortcuts on the keyboard. And we do that a lot because of the way we add automated tests. Told you before, you've done it yourself, you know. Clutter. And the more you work with automated tests, you collect more and more tests. And that means that you need to organize them in some way that makes sense. Why is that? It's easy to find a failing test. Like the report will tell you this test has failed. So finding what failed, no, not a problem. But usually, because of the way we work, we'd also like to learn not just what failed, but also what passed. And if we organize the tests correctly or effectively, let's say, we'll find these things as well. Or another scenario is when I want to add another test. Where do I add it? Like if I piled every test that I have in one file, no problem. Just add it somewhere in that module, everything will work. But usually we're not that courageous, let's say. And therefore we need some kind of a system. Now, I'm going to show you a very sample of a system. You can build your own, but this is like a team thing. When a team lives in their code, they need to know the organization and what is the meaning behind it. So I'm not going to tell you like use this what I'm going to show you, but it's an idea. Another things that we do, and it happens a lot in web tests, also happens sometimes in API tests, but web tests like a very good idea, a good example for that is that they do a lot. They have a lot of steps. Like every example that you see of automated test starts with login, right? So you log into the system, you do a couple of clicks here, navigate, blah, 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 blah. That's a lot of things. Having a lot of things to do creates two problems. One is when it fails, you have a problem with what actually caused it and so on. It's hard to reproduce, but that's not what we're talking about today. What we are talking about today is reading the tests. If they do too much, it's hard to understand what is the important stuff, what is not the important stuff. And there's a way to write these tests in order for helping ourselves in the future to understand what's happening. Again, what we're trying to do is save some time. So 3 months from now, after I've written the tests, forgot about them completely, I'm going to look at the test and try to, as quickly as possible and as safely as possible, this is very important, we don't want to break anything that works, understand what's working, what's not working, and how we can fix that. Also, answer the question, what the hell is happening here? The final thing, and this happens with a lot with web tests, but also whatever framework that you're using for API tests or whatever, we mix a lot of languages in our tests. We have the frameworks that we're using. I'm going to use Playwright, so you'll see a lot of Playwright things like locators and awaits and stuff like that. And API calls, I'm going to use like API for the frameworks. And I'm going to try to also fill in the blanks about the domain, because I'm actually testing an application that does something. So I want to see that in the code itself. So there's a mix of languages in the test themselves, which makes them hard to understand. Makes them hard to understand means two things. I said it before. One, it's going to take more time to understand. Two, we're probably going to make some mistakes while we're doing that. So we don't want that. We want shorter time, less mistakes. We'll try to avert this. So if you see these patterns in your code, there's something that you can do about it. So yeah, let's dive in. I want to show you some code. So I'm running this application locally. It's something that I built. It's built in JavaScript, TypeScript. The tests are going to be in Playwright, but like I said, we're not going to talk about Playwright or explain what it does and so on. It's like a web test. Let's talk a bit about the application and then jump into the tests. It doesn't matter how the code looks like. So it's a 2-page application. We're starting here. We have a couple of fields we need to fill in here, a couple of checkboxes. This one, the bottom one, when I check I've read the whole term sheet and agree, enables the button. Checking again disables the button. If I click the button here without filling here the one of them, all of them needs to be filled plus a valid email. So if I don't, I get an error here. If I type something here, error disappears. And let me just fill in the blanks. This is my email if you want to get in touch with me. So if I do that and I click register, what happens is that there's a small database in the backend that saves the data. And it tells me, thank you, Gil. It actually redirects, so that's the different page. It's called a thank you page. And if I actually go directly to that thank you page, it asks, who are you? That's the whole application. Excellent. So,
Gil, I'm disturbing you for just 1 second.
sure.
Someone wrote on the chat that they're having a hard time hearing you. I can hear him well, but can someone else please confirm that the audio sounds solid, so we'll verify that we're all good? If you can type, if you can hear Gil.
I can talk so you can hear.
Yes, that would be. Okay, thank you everyone so we are good. Go on, sorry about that.
Okay, thanks.
Local
Excellent.
issues, but you are well heard on the recording. So the person who wrote to me, if you'll have problem hearing, you are sound strong and sound good on the recording, which is what we wanted to verify. Go ahead, thank you.
Okay, so what I'm going to do is go a step-by-step example. So I have a couple of steps here, a couple of tests here. I'm not going to go into Playwright. If you don't have experience with Playwright, I think you should get some experience with Playwright. But the things that we're going to talk about, like I said, are not like platform specific. So I have a test for the startup that I'm finding the texts and the text boxes and checkbox. By the way, I've written this by hand really, but if you generate the test, like if you go to Playwright, and Playwright has a code generation tools, and a lot of frameworks today have that as well, you'll get very similar text. So if you don't touch it, it will stay like this. Now, also, even if you're familiar with Playwright, you'll find yourself putting comments here, because like these are really the same lines over and over again. So by putting, if you put comments in your code, it probably means that somebody needs more explanations. So this is the first test. Going to the main page and finding that everything is enabled or disabled or not filled. And then I have a whole things about validation, about when the checkbox enables the button or disables the button, and the error appears or doesn't appear for the first name and the last name and the email and the wrong email. So lots of hard-coded things here, and very long test, this one. And this one for enabling disabling button. I was smart enough to separate that from the errors and the whole process. And at the end, there's another one that checks that if you go to the thank you page, it shows you the who are you. So I've put everything in here. So now let's start going step by step and start fixing stuff. So the first thing I'm going to do is a lot of duplications here. So page get by role text box with the name first name means find me the text box which is the first name. You probably understand that. But look how many times I'm doing this. Like I find it for the last name and later for the checkbox again and again and again. Like I said, if you're generating the code from scratch with the tool, it will generate the code again and again and again. We don't want that. So first of all, I created a locators file, put all the functions here, get title, get first name text box, get last name text box, get email text box, and so on, and replace them in the text. We call this extracting functions or extracting methods. And already, as you can see, it fits in the screen better, which is fine. It's not great, but it's better. And all I did was like extract things. And you can see that we already starting to not miss the comments. The code that we write kind of make the comments a bit redundant. Okay, so that's cool. But everything still stands and sits in the same file. And this is a problem apart from the things that we discussed already, like where to put the next thing, and which are the interesting things for us to see if when a test fails. Another thing that is interesting for us is also adding the next test when it appears. But look at the screen right now. You look at the size of the scroll bar, and you already get like I don't want to touch this code. And big code has a frightening effect on us. So if we cut it into different test modules and put one or two in each one, we'll feel a lot better about reading those. And psychologically, this means that we'll understand them better, and that means that we'll make less mistakes. Everything will be cool. So let's organize those. So what I did is created a couple of folders, one for the registration page, one for the thank you page, and one for the whole workflow. So this is a way to organize things. Also for the registration, I separated the startup test and the behavior test, the validation and enabling and disabling the button. Just move stuff around. Thank you page, as its own show test, and it's already starting in the workflow. The whole workflow sits here, already starting to at least make sense to us, and we feel better about this. But obviously, we're not done. Usually, if you worked with any framework before, any test framework before, even in Selenium, which is not a test framework, you probably use some kind of jest or whatever test framework that you do. you usually have some way to collect common setup or common cleanup together. Now, when these tests sit by themselves, they don't require some common setup, but in the behavior, I actually always navigate to the same page. So that's the application, and I check the checkbox in order to enable the button. So this is a common setup, and I can move it to a common setup, which looks like this. We have a before each, so we move common setup or common cleanup to this, and the tests become shorter, which is cool, because shorter is better. Okay. I know that doesn't make a very big impact. By the way, if you work with Playwright, there's something called fixtures where you can use common setup like that across modules, not just in the same module. So that's a cool Playwright thing. Okay, so we did that. Things are beginning to look more clear than that, and we removed the application. Let's look at this thing here. So this is a long test, obviously. And we have a lot of those in web tests. We do all kinds of steps, and when we have a chunk that checks one thing, like the first page, and then we navigate to the second, we continue from the same point. Like I said, having tests that do a lot of things, they can fail on a lot of things, not be very specific. Something can fail at the end of the test because something that we did like 3 pages ago. And these things are hard to read, as you can see on the screen, but they are also hard to debug, to understand, to isolate the problem. So if it's possible, we can split those into smaller steps. Some people don't like this, but I do. So let's see how this looks like. The idea when you're splitting tests is that you basically start from the same starting point and then go there. You don't continue from the last point where you got there. So if you look at the tests after they split, cool things happen. First of all, they're shorter. Like I said, shorter is better. We understand them better. We make less mistakes. Also, we've given them names. Like this chunk checks about validation error when all the fields are empty, rather than this one when the first name is empty, and so on and so on. Everything starts from the common setup. We know how to read this stuff because we have experience with using test frameworks. So splitting, good thing. Are we done? No, as you can see, we have a lot of more steps to go. Okay, meaningful names. Now, so far I used get terms checkbox and get register button and get first name text box, which are not really a problem. Like most people understand what checkboxes are, most people understand what buttons are, and all that's true for clicking and filling, and you get it. It's not enable, disable. This is like our day-to-day language. So most people will not have a problem reading this, which is okay. However, think about this, for example. So that means find me the first name of the text box and put A in it, which is nice, but it's like if you were explaining this to a user, you wouldn't tell find the text box and put A in it. You know, type something in the text box, right? So why not write this in the test itself? So let's look how this works. And this is just by renaming. So check term box or button should be enabled or uncheck or click register. This begin to look like user language rather than page locator language. And we want that. We want to abstract the details. For many reasons, abstraction is something that is a very common principle for good software practices. Abstraction means we abstract the details. We don't tell anybody how things are done, but what they should do. So our test beginning to look more like I would ask a user to perform this. Think about this like enter your manual tester thing. First, you click the register, then you see the error, then type anything in the first name, and then the error should be clear. So the language becomes a lot more day-to-day and not like how the page is built or how the test is built. And that's cool. You see a lot of the pages here, which is a Playwright thing. Kind of annoying. Also, Playwright in JavaScript or in TypeScript has a lot of everything's asynchronic, so you see a lot of awaits. Can't get rid of that. And other languages, for example, if you did the same thing in Python, it will look a bit better. Okay, so that's cool. And what can we do? Okay, so this is okay. Things that I kind of repeat again are like the hard-coded stuff. So we have this, the main page. Playwright translates that into the main page, but also in apart from the locators that we have here, I created the functions in asserts and actions. So button should be enabled and stuff like that. It sits here. They're wrapping around the find locator and do something, and actions do something like get the button and click. So this is excellent. But we do have a couple of literals like a hard-coded stuff. So type anything, I can type anything. I chose A. Let's look at how, if I take the literals out, how they look. So I created a file, extracted things into here, and put the URLs that I'm pointing to, and the API that I'm pointing to check the data, and also the values. Because if you look at before that, the registration workflow looks like this, which most people will say it's okay, like check the terms box, fill this in the first name, second name, email, click the register, should display the name, and here there's a function that checks that the data was added to the database. And it's okay, but look at this code and imagine yourself like 3 months from now, 6 months from now, and you look at these values and you say, well, these kind of values are okay. Yeah, this test looks okay to me. It probably works because the values are okay. But think about it. In the first name, remember what I told you about the instructions about this application. The first name and last name can contain anything but spaces, but the email has to be valid. Otherwise, the test will fail. If I run it without a proper, remember, it will give you an error. So there's a difference between this value and this value, for example. Because this can be anything, but this should be something. So when I extract the constants, I can give myself hints. So I will call this one any first name and any last name. This one I will call valid email. So the test will look like this. So when I read it next time in the future, I will know what things are important. Like I use the prefix any for whatever. But other stuff, it could be like a specific or valid or give myself hints. What is important to this, because if I'm going to change values, I need to know how to change them if I can. So leaving myself hints about how to read the tests in the test itself, which is kind of cool. We can do a lot of things with text. Okay, before we continue, let's I'm going to switch back to the slides because we're going to talk about something completely different, which is not really simply completely different. Let's talk about the page object model. Because if you have some experience with web tests, you probably heard about it. Specifically, Selenium kind of took over it. And they have like page object model and page factory inside the code. But basically, the idea is that you'll collect all the locators or handles or elements handling in one place. You already did something similar to that by extracting the functions, right? I did like but it's not. I separated them by another semantics. I put locators in one place and asserts in one place and the actions in another. But the idea about page object model is that it kind of put all the handling of the page in one place. Why is that? Two things. We already seen one effect of something similar, which is it makes the code, test code, well, the original test code, the main one, a lot more readable if we do it correctly, because we hide the details, no more locators, no more elements in the page. But the second thing is management. Sometimes you can do things that are a couple of operations on different locators, so you can wrap things out. So this is abstraction, basically. It's just abstraction that we talked about. So our method of separating the tests kind of separate them by pages, right? Like these are the tests for the registration page, and these are the tests for well, the thank you page, but there was something else that going through them. So just it's a good idea to use page objects as a pattern. Let's see how it looks like. So let's dive back in. So we are here, for example, and we have just the tests, right? What we did until now, but with our POM example, I'm going to do this in 2 steps. I'll tell you why. First one is creating our page objects. I also created a page factory object that creates them. So it looks like this, finds the locators and has the method for typing last name. All the actions that we have go into this page object. The thank you page has a lot less here. And there's a page factory. This is not Selenium page factory, but it does exactly what the Selenium page factory does, which is create the page object, return it, and initialize it also. Okay. How does it look like from the point of view of the test? It's very similar, really, to what we had until now, right? With page factory and to create the registration page, and all the operations that we did until now sit in the contents of the registration page. We don't have this annoying page, playwright page, hanging around. A lot less technical stuff. Technobubble, remember, we don't like that. And other than that, it looks okay. I also created a submit thing, which I want to show you on the page object. So remember, I have 2 types of clicking on the button. The first one is the one for the arrows, which doesn't navigate. But in the workflow that we see, it navigates to another one. So I created 2 methods on the page object. One is called click button, which I'm using in the error tests. We just clicks on the button. But the submit is the one that does the navigation. So I'm doing the clicking, waiting for the navigation to complete, and then page object now points to the thank you page, a playwright thing, and I'm returning my thank you page so the test can use it, and it again looks like this. Now, why did I not put should display thank you with name on the thank you page? This is a playwright thing, which is something that you probably don't want to do, but I'm showing this because if you're going to look at the playwright documentation, you see that from their point of view, page object doesn't include asserts, just the actions. No, don't do that. You probably don't want to. You see, I've already lost the actions going into this step. We can put the asserts as well. So lose the asserts, and our tests will look like this. Verify message display with any first name, and then now I can see the connection between any first name, any first name. I forgot to show you something that is sort of important, which you need to be aware of, and it kind of connects to this. So I can see any first name, any first name, any first name, and I know that, these things are connected. Let's look at our test that does Where is it? I want to show you the test here. Sorry, here, the behavior. So let's look at this test, for example. So remember, checking the terms checkbox enables the button, doing that again, disables the button, and so on. So, well, basically, these are the lines here: uncheck and verify button is disabled, or other stuff as well. There are things that are basically semantically connected, but you don't see it in the code. So if I told you now that checking and unchecking the checkbox enables and disables the button, you would remember that. But if you look at the code, there's just these two lines. 3 months from now, you won't really remember the connection between them, because the connection is semantic. It's not about which locators you find, but there's a semantic connection that says, when we do this, we expect some kind of behavior. And this is a system behavior. It's a rule behavior, business rule behavior. These are hard to see in those things. If we, again, going into the page object or the code that we wrote until now, even the tests, we don't see the connection between different parts of the page. We can try though, although it will not be perfect. And the way to go around this is look at what we've done until now, including this. We're still looking at the test and saying this is a step-by-step of doing operations on the page. And we're clicking buttons and we're checking and checkbox, unchecking stuff. And like I said, if I told you, you'd understand. Like, there's no real problem here. But we can go a bit more. So let's look at, before we see the final one, look at the registration page. So basically, remember what we're doing is creating the registration page and checking the term box. Why are we checking the term box? Because we want to enable the button? No, that's what the page does. What we actually want to do is agree to the terms, remember? So why don't we write it like this? So create the registration page, agree to terms, first name is, last name is, email is, submit, and then display thank you with this. And it's not like a big difference of what we had before, but we're trying to tell the story of the user, what the user does with the application, rather than what the page does on the screen. It's a good idea. Remember, what will happen in 3 months from now is that this test will fail, and this is what you'll see on the screen first, and then you have to remind yourself what the hell is happening here. And telling this test in the language of the application rather than elements on the screen will get you in there more quickly. Remember, this is what we wanted. Shorter time and a lot more safer than it is to change stuff. Okay. Let's dive out. So we didn't talk about everything about clean tests. If you're interested, I'm doing all the workshops on clean tests, including web tests. But we talked about a couple of things that are properties or patterns that we talked about. First of all, the clear. They tell us the story of what's happening. They're focused. Each test that we had at the end is focused on a specific thing. So if this one fails but others don't, we can find out where the real problem is rather than debugging everything from scratch and the login. They're organized in a way that tell us not only these things run together, they're about the same subject, they're focused on these same things, but also what they're not. They're not for the register tests do not handle the thank you page tests. We can run just the register page because they sit in another folder. It's kind of property of the test framework, but it's easier again to use the tests in order to find what the problem is, and not run the entire suite of tests in order to find it again if things are running. Remember, when you're trying to rerun things because you're not sure if this should fail or not fail, you probably want to just run a subset, and organizing them makes it easier to do that. And finally, to tell the story not from how the page is operated or managed, rather than by how the user will operate the system. And because we're users of the system, remember, when we're like, we don't remember the details. We remember them now because we just wrote the test or just copied it. But 3 months from now, 6 months from now, we won't remember any of it. So our entry point when something fails will be the test, and we try to leave it as meaningful to us, usually as a user of the system rather than operator of the system. It will help us make less mistakes, and get back to the new stuff, new shiny stuff, as quickly as possible. And that's what I wanted to share with you today. That's what clean tests do. They help you. And I hope you take some ideas from that and go back to your tests. Or if you don't have any automated tests, start writing them the right way. And these are all kinds of ways to find and connect with me somewhere. And usually it's easier to do this either through LinkedIn or what the YouTube videos, or go TestingGil.com. But other than that, I want to thank you for watching today. And if you have any questions, please write them in the chat, Q&A. Where do we write them?
Yes, either way would work on the chat. We can write it on the chat. We'll
I'm going to leave Thor here. It makes a good impression.
to put it in the context. I actually have one question written here, Gil, to begin with, if that's okay with you.
Sure.
Might be trivial, but the question essentially is, when is clean web testing not the right fit? You
It's
mentioned
always the right fit, but
the several ways on how it should be done, but is there a time when it's not a good fit?
The answer is of course there is, and the reason is there are two reasons. The first one is time. We don't have time to do this. The problem is that we never have time to do this anyway. So we kind of say, test works, let's move on. We have like 500 tests to create. I can't do this like for everyone. So if time is a problem, what we're doing in our hands really is a calculation. Should I invest with this time in making this clean web test clean? And would this investment be making my life easier in the future? So as a rule, we'd say, well, if this is the last time we actually see the test, can write it as ugly as we can, and no problem. The problem is that we know how life is, and we will come to these tests, we just don't know which. So first of all, if you have time pressure, I won't tell you like stop everything, stop the release until you actually do this. But the problem with this is that most of the time you will not have time to do this. So I see that as an excuse really, but reality sometimes trumps. The second thing is something that is more of a view of why people don't do this rather than why shouldn't I do this. And this is about skills. A lot of automation people don't come from development background. So the patterns that I talked about today, usually people coming up of development, they kind of drilled into their brains that they shouldn't duplicate code, or do some refactoring to make the code better. And like I said, people in development kind of see their code like, we're going to go in there again, so we better leave it better. So the motivation and skills may not be there. And again, this is not a problem. Well, it's a management problem, really. But some people don't have the experience, the skill, the support to make changes to this, because all people are around them making ugly tests. So why should they make the ugly duckling look better? So could be like different situation where you would say, well, I don't know how to do this. I don't know how to do this well. I don't know if I should do this. But my message is probably it's not something that you start today on 1,000 tests. It's something that you start in very small steps. And some of the tests that are written were written like 3 years ago or 5 years ago and are passing, don't touch them. Touch them only when you actually going to change them, or the code changes or they fail something. When you go into the code, this is the time to change. Don't introduce any risks to something that already works, although it may be ugly.
That actually makes perfect sense, because in reality, there's never enough time.
Right.
So I would take your words and essentially, even if you don't have time, I think this is a framework to think of, that even when you write it, you should write it as clean tests, but you don't start restructuring, refactoring everything that was already.
No.
Because if you look at this project this way, it's just become too huge to be realistic. But if you decide, if you adopt it as a way of thinking, then this is something that can be made even in gradual steps, and then add and adjust one test at a time, in a way.
If you compare it to actual production code, if you want to refactor like a service or something like that, it's going to be a huge chunk of code. Tests are smaller, like that, maybe like the smaller like this, and you can make them a lot smaller, but they are very, usually they are not dependent on other things. So if you want to start doing these things and practice on them, like tests are very good point to select this one and start on it. And the more you do this, it will become easier, safer, and quicker to do. But you first have to put it here and think about it.
Question. We still have 2 more minutes, so if we can squeeze that one in. Is there any coding language that allows to write code the most clean way that you recommend? Is one language better than the other?
No, some slang.
Which kid does he prefer?
No, it's not like that. Well, it may be. Each language comes with its own ideas of how you should write code. The things that we talked about today, removed application is not language related. Every language that you use, you probably don't want to duplicate code. Renaming, we changed names. Everything that we do can be done in any language. So things are not language dependent. These patterns can be done in any language. Some languages, the same things or the same tests, for example, will be at different lengths. So if you write the same test in these things that we done to do this in Java, will probably take longer than we did in TypeScript, or Python will be shorter. So it's not about the cleanliness of the language, but in terms of clean code, we usually look at blocks of code and we understand them better if they're shorter. So Python, for example, will probably be a bit more understandable than Java. But if you know Java, write tests in Java. It doesn't make sense to just write tests in the new language that you just heard about. So
thank you. Perfect. That's the questions that we had now. I'd like to use this opportunity to thank Gil for a very insightful session, to thank you all for joining us today, to invite you, actually also relating to Gil, next month on November 12th, PractiTest will be hosting the online TestConf. That's a free testing event on 2 different time slots. Go to the www.onlinetestconf.com. Gil is also giving a session then. So if you enjoyed this session, you'll probably like his session, or you probably find it interesting. I surely hope so. There's additional 7 sessions other than Gil's, which are, I hope, as good. So invite you to join them as well, and to keep in touch with us, join our webinars, try us. Thank you all for being with us today, and have a good morning or rest of the day. And I agree, that was a very interesting session. Thank you all. Bye for now.
Thank you. Bye-bye.